Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. We have square root of x square plus a square. So what we've been given is dy by dx and we've been asked to find y. My y is nothing but integral of the given expression. So let's write down our y. So that's my y. I know that my y is not in a very simple format whose antiderivative I know from first principles. But what I see is I have a quadratic expression whose coefficient of x is 0, right? Inside the square root. We have an x square plus a square inside the square root alongside your dx, right? So the best possible approach to solve this problem is using trigonometric substitution, and it's important we identify what is that right substitution that we make. I know that my secant squared theta minus tan squared theta equals 1, which means that my secant squared theta equals 1 plus tan squared theta, right? So the best substitution that will work out here is x equals a tan theta, right? Because when I make this substitution, my dx becomes a times secant squared theta d theta, okay? And then what happens to my square root term is, let me go to the next line, and y becomes equal to integral of the square root term out here becomes square root of a square times 1 plus tan squared theta. So what you have in this inside the square root becomes an a square secant square theta, and square root of a square secant square theta is nothing but a times secant theta, right? So I have a times secant theta times a secant square theta d theta, right? So I know that I have a double A inside the integral, so I can pull out a square. So my y becomes a square times integral of secant cube theta. So for a minute, I'm going to keep my y aside. I'm just going to pick up integral of secant cube theta d theta. So the way I'm going to solve this is, so if I draw a parallel to integral of u dv, right? So the job in hand is to identify what is your u and what is your dv, right? So the way we do this is my u will be equal to secant theta and my dv is nothing but your secant squared theta d theta, right? Think about it. This is probably the best substitution that you can do because this makes your du and v as well much easier. If any of you folks are able to identify a different udv combination, please do mention in the comments. So my du becomes secant theta tan theta d theta, right? And what happens to my v? My v is nothing but a tan theta, right? When my dv is a secant squared theta d theta, then my v is nothing but a tan theta. So now I have my v u dv du, right? So I'm going to use integration by parts to solve the remaining problem. I have integral of u dv equals uv minus integral of v du. So all that we'll have to do now is substitute for our u and v. We have our u, which is nothing but secant theta. We have our v, which is nothing but a tan theta. So the first part of that becomes secant theta tan theta, right? And then come to the second part. What I have is integral of v du, right? What is my v? My v is a tan theta. Du is nothing but a secant theta tan theta d theta, right? So let's write it as it is, right? So what I have is minus of tan theta into secant theta tan theta d theta, right? And this is where I want you folks to watch this very closely. What I'm going to do is my LHS, what we started off is integral of secant cube theta d theta, right? So I'm going to write that as it is, okay? And what we have on our RHS is what we are going to do a little bit of, what can I say, jugglery, right? So what I'm going to do is secant theta tan theta remains as it is, and then minus of this part, right? The way I'm going to write this is I have integral of secant theta, and then I have a tan square theta. What is your tan square theta? Is nothing but a secant square theta minus 1 d theta, right? So now I apply the sum rule of integral to my RHS, right? My LHS, which is integral of secant cube theta d theta, I'm going to call it I, right? Let me call it I. And therefore, my I equals my first part is pretty much solved, which is a secant theta tan theta. I come to the second part. What I have is minus of integral of secant theta into secant square theta minus 1, right? So what is that? The first part to this, when I apply some rule of integral, is nothing but your secant cube theta d theta. And what is that? That's nothing but your I, right? And what happens is you are also left with a plus integral of secant theta d theta, right? Now you see the reason behind expressing your tan square theta as secant square theta minus 1, right? Now you have a I on the LHS, you have a minus I on the RHS. We're going to combine both of them and write this as 2I, right? So what happens is my 2I now becomes equal to secant theta tan theta plus my integral of secant theta d theta, which you folks must be quite familiar with, is nothing but log of mod of secant theta plus tan theta. And then I have my constant c, right? So I've solved for 2I, and solving for I is not very difficult from here on. Why? Because I have this as half of secant theta tan theta plus my log of secant theta plus tan theta plus c, right? Of course, the expression inside the log is within the mod. So that's my I, but we are not yet done with y. So let's go back to the expression y. We started off with a square times integral of secant cube theta, right? So what happens here is my y becomes equal to a square times, then we have integral of secant cube theta, which is nothing but our I, as half of this expression, right? So now what happens is all that I need to do is put back everything in terms of x, right? And that's not too difficult for us. The first part becomes a square by 2, and I open my bracket. I have a secant theta tan theta. So what is my tan theta? So let's write that down as an interim step. My tan theta is nothing but an x by a, right? And if that's my tan theta, what is my secant theta? My secant theta will be square root of 1 plus tan square theta. And what is that? It is nothing but a 1 by a times, okay? Reason being I pull the a outside the square root, and then I get an a square plus x square inside the square root. So that's my secant theta. I have my tan theta, I have my secant theta. So now I go to my expression y and I try and rewrite everything in terms of x, right? So what happens to my first expression? Secant theta tan theta becomes x by 8 times. Then I have a 1 by 8 times square root of x square plus a square. So I write it as it is. And then I have a log of mod of secant theta plus tan theta. So I already have those with me. And if I express this in the x by y format, what I will get is x plus square root of x square plus a square in the numerator, and then I will get an a in the denominator, right? So now if I take my a square by 2 inside the bracket, what happens to the first part of y? The a square gets cancelled and I'll be left with x by 2 times square root of x square plus a square. So that's my part 1. And then I come to my part 2 and I have a log of mod of a by b, which is nothing but a log a minus log b, right? And remember, I have my a square by 2 as well. So when I use the formula log of a by b equals log a minus log b, so what happens is I can combine the constant with the log a expression and I can express that as one single constant. So what happens is the log of x plus square root of x square plus a square by a is nothing but log of x plus square root of x square plus a square minus log of a, and that log a also being a constant, we combine it with c, right? So that's why we are now in a position to express our final answer uh, as x by 2 times square root of x square plus a square by 2 times log of mod of x plus square root of x square plus a square plus c1, right? So let me highlight my final answer in pink. So there we are. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.